Hello everyone, I hope that I am audible to all of you. Hello everyone, I hope that I am audible to all of you and my computer screen is visible to all of you. Please reply if I am audible. One student replied that yes sir, you are audible. Another student replied that screen is visible. So thank you all. Today we are about to revise and one of the most important chapter of 8051. Name of this chapter is, I hope now my voice is clear to you. I hope now my voice is clear to you. One student has replied that a bit louder sir. So I think now my voice is yes. Shreyoshi replied that my voice is properly audible to all the students. It is nice to see that all the students have joined once again here. Almost 1122 participants has joined. It will be appreciated if you inform your friends to join once again. So today we are discussing the we are revising microprocessor microcontrollers theory, and we are discussing the assembly language programming of Intel 8051. It is lecture number 1. It belongs to module 3, chapter number 10. We are repeatedly discussing the assembly language programming of 8051 as because it is important, it is useful, and it is very important for the final semester examination. I hope that with the help of the simulator of 8051, the it has already been started. I hope that with the help of the 8051, it has already been started. You are observing that first program, write an ALP in 8051 for addition of two 8-bit numbers. Sum of these numbers should be 8-bit. We are observing that move dptr hash 7050 is basically the first number. MOVX a comma at the rate dptr is our second instruction, through which what we are doing, through which we are transporting 7050 to dptr or data pointer register, and with the help of that we are transmitting it to A or A accumulator register. MOVX is basically the instruction through which 7050 is moved to accumulator register, and move B comma A. This is another instruction through which value of A is transported to B. Next is increment DPTR 7050. We have 7050 here, and with 7050 we are incrementing it by 1, so 7051. we are incrementing it, and with the help of move B comma A, we are transmitting the value of A register, A for accumulator. We are transmitting the value of A register to B register. A register value is suppose 02, and at 7050 suppose we have say 02 value. Now whenever we store DPTR to 7050, DPTR value is 7050, and DPTR is pointing to this location. Now move DPTR hash 7050, so we are transmitting the value 7050 to DPTR. Now move x A comma at the rate DPTR. So what we are going to do, we are transmitting the value of A register to DPTR register. So value of A register we are transmitting it to value of A register, we are transmitting it to B register, and value of A register we are transmitting to B register, and move B comma A. So we are transmitting the value of A to B register with the help of the third statement. With the help of the fourth statement, increment DPTR, so we are incrementing the value of the DPTR or data pointer register. So data pointer register is now 7051, that is the value of the data pointer register. Data pointer register value is 7051, that's the value. Move x A comma at the rate DPTR, so we are transmitting the value of DPTR to A register. Let's say the value of 7051, that location, this is the value of DPTR. Let's say the value of 7051 is suppose 03. Now we are transmitting with the help of this statement, move x A comma at the rate DPTR, we are transmitting this value to A register. Now the value of A register is 03, value of B register is 02. Now we are going to add both of them. The result is 05, which is to be stored at A register. Next add A comma B. Now we are transmitting the value of A comma B. So we are transmitting the value of B register. So we are basically adding the value of A register and B register and storing the value to A register. Now increment DPTR. So we are going to increment the value of the DPTR. Increment DPTR means we are going to increment the value of the DPTR. So DPTR becomes 06. DPTR becomes 7052. That's the value of the DPTR. Okay. Now move x at the rate DPTR comma A. So we are transmitting the value of A register to DPTR. So 70 7052. So value of A register which is 05, we are transmitting it to value of A register which is 05, we are transmitting it to 7052. Okay, then rate we are going to stop our instruction by rate instruction. Rate stands for return, and with the help of this statement we are going to stop our operation, and we are going to return we are going to stop we are going to return to our base address. So again I am repeating this once again. First of all, we have 70 repeating this once again. Let me clear the screen, as because this is a doubt clearing class, so over time again and again and again and again you need to repeat it once again, repeat it so that it will be clear to everybody. So first of all, we are basically storing 7050 to DPTR, the data pointer register, then a comma at the rate DPTR. So we are moving 7050 to a register. Now 7050 value is suppose 02. Now we are moving it to a register. Now a register value becomes 02. Now this value we are transferring to the B register. Now B register value becomes 02, and now increment DPTR. So DPTR is incremented by 1, so it is 7051. Now it is not pointing 7050, it is starting pointing to 7051. Let's say the value is 03. So move x a comma at the rate DPTR, it indicates that from 7051 03 value will be transmitted to accumulator register. So accumulator becomes 03. Now add a comma b, that means the value of a, that is 03, and value of b 02 will be added together, and result will be 05, that should be stored in a. So a will be 05. Next, increment DPTR. So we are going to increment the value of the DPTR or data pointer register. Now DPTR is going to be 7052. Now DPTR is pointing to 7052. Next, move x at the rate DPTR comma a. So what happens is the value of a register a, that means we are transmitting it from a to 7052, the address which is pointed by DPTR. So we are transmitting this value which is transported from a to 7052. That means the value of a becomes 05. Okay, then rate to stop the operation. So this is our first problem. Our next problem says that write an ALP for subtraction of two 8-bit numbers. One number is EF, is in the accumulator register, and another number is 45, which is in R0 register. So first of all, let us draw it. One number is EF, one number is EF, which is stored in accumulator register. Another number is 45, which is stored in R0 register. Now we have 2-bit numbers. Now after subtraction, the result will be stored in A register. Now after subtraction, the result will be stored in A register. Result will be stored in A register. So first of all, we are transporting the value EF. Hash indicates the value. We are transporting the value EF to a register or accumulator register, because initially the accumulator will be stored by some garbage value or any other values. Next, 45, we are transporting the value 45 to R0 register. Now R0 register should be assigned with the value 45. Now sub SUBB A comma R0, that means what happens is that the value of R0 register and value of A register is now both of them going to be added together. Now R0 subtracted together. Now R0 register value is 45 and A register is EF. We are going to subtract them. So EF minus R0. Now if you write EF, E can be written as, F can be written as 1111 and E can be written as 1110. Similarly 45 can be written as 45, so it can be written as 0 0 1 0 0, and 5 can be written as 0 1 0 1. So in this way it can be written 1 1, that means 0, 1 0, that means 1, 1 1, that is 0, 1 0, that is 1, 0 0 0, 1 0 1. So 1 1 0, 1 0 1. So we are observing that this is basically practically hexadecimal A. This is also practically hexadecimal A. So we are subtracting them with with the help of the SUB, subtract with borrow instruction, so that the result is generated. Now result is double A. Now after subtraction the result is double A, and after the result is going to be stored in the accumulator register or A register. It will store the result. Accumulator register, register will store the result, and with the help of the return statement we will return it, we will return our program. Write an ALP for one's complement of an 8-bit number. So this is also very interesting program that we can able to observe. So let me take some question if there is any before I move further. If you have any kind of question or if you have any kind of doubts, then please do not hesitate to ask. Please do not hesitate to ask if you have any kind of question or any kind of doubt. Please do not hesitate to ask. One question, sir, hash 45 is the value of the register. Yes, hash 45 is the value of the register. Hash means value, 45 is the magnitude of the value. Hash means value, 45 is the magnitude of the value. Hash means value, 45 is the magnitude of the value. So we come to our next question, that is third question. In this third question we shall discuss that write an ALP for one's complement of an 8-bit number. So first of all, we are observing that we stored 45 value to the accumulator register. Now we are observing that 45 value is basically now stored in the accumulator. This is basically an immediate addressing mode because we are directly transmitting the value to the accumulator register. Next is CPLA. CPLA means we are basically making the complement of A register. So CPL is basically the complement of A. So A register we have a value and we are making the complement. So 45 we are making a complement, so 4 becomes 0 1 0 0 and 5 becomes 0 1 0 1. That is the value of 4 and 5. So the value of A register will be 0 1 0 0 and the value of A register will be 0 1 0 1. So that's the value of A register. Now CPLA we are going to making a complement of this value. So this is typically an ones complement, so it will becomes 1 become 0, 0 become 1, 1 become 0, 0 become 1, 0 0 that will become 1 1, 1 become 0 and this 0 becomes 1. So 1 0 1 1, 1 0 1 0, that's the basically value. So what we are going to do, we are going to transmit it to at 7050 is basically a location. Move DPTR, that means now the DPTR is now basically loaded with 7050. DPTR is loaded with 7050. That means DPTR is pointing the location 7050. Now movex at the rate DPTR comma A. So we are going to, this is now the final value of A, which is 1011101010. Now 1010 is typically A, we know that, and 1011 is typically B, we know that. So what happens is that whenever we perform movex at the rate DPTR comma A, the value of A, which is BA in hex, will be transmitted to the location pointed by DPTR. Now here DPTR, the location pointed by DPTR is 7050. Now the 7050 will become BA. Now with the help of the rate instruction we are going to stop our program. Write an ALP for 2's complement of an 8-bit number and the result should be stored in 7050. So first of all, CLRC. So CLRC is basically, and so it's a 2's complement. First of all, CLRC, that is clearing the screen. It is important that we must clear our screen before we execute any kind of program or problem. So we are using this particular instruction. Move A comma hash 4F. Now hash basically represents the value, and 4f is basically the value that we are talking about. So move a comma 4f, that means in a register we are going to store 4f value. We are going to store 4f value in a register. Now CPLA, we are going to basically make a complement of 4f. So 4 represented by 0 1 0 0 and f represented by 1 1 1 1. That is how the 4f is represented. So now this is basically the value of a. Now whenever we perform the ones complement with the help of the CPL or complement operation, naturally this will be complemented. So the complemented value of the a register will be 1 0 1 1 0 0 0 0. So that's the value. 0 0 0 0, we all know that this is basically hexadecimal 0, and 1 0 1 1, we know that it is basically hexadecimal b. So b0 is the value. Now if we add 1 with it, 0 1 with the add a comma hash 0 1, so we are going to add 1 with it. So 0 plus 1, that is 1. So b1 is basically the value that we are going to store in the a register. So at a register we are going to store b1 value, which is nothing but the 2's complement of 4f, because 4f when once complemented it becomes b0, and after adding it 1 it becomes b1. So b1 is the value of 4f, 2's complemented value of 4f. Now move at dptr comma hash 7050. So it indicates that the value of 7050, which is a memory address, it is going to be stored in the dptr or data pointer register. So now the data pointer register becomes 7050. So that is dph dpt h, and that is dptl. That's the value. Now naturally this particular register will going to point 7050 location. Now the value of a is going to be transmitted to dptr 7050. Now what happens is that the value of a register, we need to find it out. Value of a register is b1, that should be transported to 7050 for storage. So b1 is now going to be transmitted here. After that we have nothing to do, so we are going to end this with the help of the ret instruction. Ret stands for return instruction, which will return our control back to the initial point or starting point. Now CLRC means clear screen. We are basically clearing the screen. So this is CLRC is typically basically basically a command that is used here to clear the screen. Okay, next move a comma hash 4f, or clear the counter also, you can able to say that. Move a comma hash 4f. Here hash 4f is basically the value. We are going to transmit it to the a register. We are going to transmit it to the a register or accumulator register. accumulator register or A register. So 4F is the value, we are going to transmit it to the A register or accumulator register. So 4F value we are transmitting it to A register or accumulator register, and then we are going to make the complement of the accumulator. Complement of the accumulator. Next, add A comma hash 01. So we are going to increment the value of the A register. So we are going to add the value of the A register. So the value of A register is going to be incremented by 1. So it will be it is initially it is 4F 4F. Now after once complement it becomes FB0. Now after adding 1 it becomes B1. So DPTR 7050. So we are going to transmit 7050 to DPTR register or data pointer register. Now MOVX A at the rate DPTR comma A. So we are going to transmit the value value. We are going to transmit the value to DPTR register. Then we are going to stop our program. Write an assembly language program to add two 16-bit numbers using 8051 microcontroller. Is our next program. So it comes in WBUT, or now known as Makout, or Maulana Abul Kalam Azad University of Technology. At 2013. So let us assume that a 16-bit data stored in 7050 and 7051. So and a 16-bit data is stored in 7060 and 7061 location, and after addition the result stored in 7070 and 7071 location. So let me assume that the higher order data stored in 7050 and 7060 location and the lower order data in 7051 and 7061 location. So after addition the higher order result is stored in 7070 location and the lower order result is stored in 7071 location. So first of all let me draw the program in this way. So a 16-bit data is stored in 7050 and 7051 location, and other 16-bit data is stored in 7060 and 7061 location. So first of all we are going to basically store the data at 7050 and 7051 location, and other 16-bit data is stored in 7060 and 7061 location. So 16-bit data is stored in 7060 and 7061 location. So a 16-bit data should be stored, that is 8050. That data is sorry, let's say the data is 0101. That's the data that is stored in 50 and 7051 location, and the other 16 bit data is stored in 7060 and 7061 location. So other data is stored in 7060 and 7061 location. So the data is suppose 0202. So let me assume that the higher order data is stored in 7050 and 7060 location. So this is higher order data, and this is also the higher order data. This is higher order, this is higher order, this is lower order, this is lower order. As simple as that. And lower order data is stored in 7051 7061 location. After that, the result higher order data will be stored at 7070, and the lower order will be stored at 7071. So 7070, another one is 7071. So we are going to store the result over there. This is higher order, this is lower order. So we are going to store it over there. So how we can able to do that? So very simple. First of all, at 705 from 7051, we are going to transmit the data to the DPTR or data pointer register. So from 7051, we are going to transmit the data to DPTR or data pointer register. So now the data pointer register value is 7051. That is the value of the data pointer. Now MOVX A comma at the rate DPTR, that means value of the DPTR or 7051, value of the DPTR, that is 7051, will be transmitted to A register, move B comma A. So the value of A register will be transmitted to B, value of A register will be transmitted to B. So value of A register will be transmitted to B. So A register value suppose transmitted to, value of the DPTR will be transmitted to A. So suppose the value of 7051 is 01. Now this is transmitted to A, so A becomes 01. Now move B comma A. So the value of A will be transmitted to B register. So B becomes 01. Next move DPTR comma hash 7061. So 7061. So we are transmitting the value of 7061, that is 01, to 706101 to 706101 to the DPTR, data pointer register. Now data pointer register becomes 7061. Now MOVX A comma at the rate DPTR. So the value of 7061 will be transmitted to A. So the value of A register will be 01, that is from 7061. Now the value of A is 706. What is the value of 7061? Value of 7061 is 02. Very sorry. Value of 7061 is 02. Now value of 7061 is 02. We are transmitting it to A. So now A becomes 02 and the B becomes 01. Now we are simply going to add both of them with the help of add A comma B instruction. Now what happens is that 02 and 01 will be added, and the result is going to be stored in A register, that is 03, and at the carry register, we are going to store the value or carry, that is 00 carry. We are going to store it here. Move DPTR comma hash 7071. So we are going to transfer the value to 7071, move at the dptr comma hash 7071. So we have 7071 to dptr or data pointer register. Now we are going to transfer 7071 to dptr. So we are going to transfer 7071 to dptr. We are going to transfer it. Next, move at the rate dptr comma a. So we are going to transfer the value of 70 transfer the value of a register, which is 03 here, to 7071. So now 7071 becomes 03. So in this way you are observing that basically you are observing that 01 and 02 is added, result is 03, and 03 is going to be stored at basically the 03 is going to be stored at basically the in the a 7071 location. So now the 7071 is filled up with 03. Next, move dptr comma hash 7050. So what happens is that now 7050, what happens is that we are going to transfer we are going to transfer 7050 to dptr or data pointer register. Okay, now movex a comma at the rate dptr. So whatever be the value stored at 7050, that we are going to transfer it to a register. So this is my a register. What is the value stored at 7050? Value stored at 7050 is 01. So that 01 value, 7001 value is transmitted to a register. 01 value is transmitted to a register. Next, move b comma a. Now we are going to transmit the value of a register to b register. Move b comma b register. Next, move dptr comma hash 7060. So what happens is that from 7060 location we are going to move the value to dptr or data pointer register. We are going to store 7060 to dptr. Now what happens is that we are going to transfer we are going to transfer the value of 7060 to a register. Now first of all, value of 7050 transmitted to a register, and from a register it is transmitted to b register. It is transmitted to b register, and so b register value is 01. Next, what happens is that now 7051 value, which is 01, it is transmitted to b register, and 7060, whose value is 02, whose value is 02, 7060 value is 02, 02 value is transmitted to a register, transmitted to a register. Okay, now this 02 and b value, now they both of them are going to be added together. Now after this addition, the result is 03. So 03 is the value that will be stored in the a register. Now we are using the adc a comma b instruction. For that, it shows that the value of the a register, which is 02, and the value of b register, which is 01, both of them are added together, and result is 03, which is to be stored in a register. Next is dptr hash 7050. So what happens is that from 7050 memory location, we are basically transmitting we have 7070 is in our DPTR or data pointer register. Okay, so what we are going to do is that we are going to transmit 7070 location 7070 from 7070 location we are transmitting it to the A register or accumulator register. So sorry, we are going to store the value to 7070, or the value of accumulator should be stored in 7070. So move at the rate dptr comma a means the value of A register will be transmitted to 7070, that is 03, and then with the help of the rate instruction we are going to stop our operation. So this is all about the programming of 8051. We have discussed 5 programs. Now if you have any kind of doubts, you are allowed to ask. I am happy to answer your questions. One question come that sir, what is the difference between MOVEX and move? MOVEX is basically the indirect addressing mode. In this MOVEX instruction, basically the value of a memory location, say 7050 is transmitted to accumulator via DPTR or data pointer register. Any other question from your side, or else we can stop it here? Okay, then thank you all for joining this lecture.